அந்த அரேஞ்ச்மெண்ட் இல்லையா ஃபர்ஸ்ட் அலாம் நம்பரு அலாம் இது டெஸ்ட் அலாம் நம்பரு அதுக்கப்புறம் ஆப்ஜெக்ட் கிளாஸ் சப்ளிமெண்டரி இருக்கும் அதுக்கப்புறம் மட்டும் இருக்குது அலாம் டைப் டிஸ்டிங்ஷன் நேம்.
So organic design, all these things we have learned, and the prometry we have designed. Okay. So organics next is aesthetic also we have seen. Okay, so this is another aesthetic. Okay, so aesthetic basically deals with the style and appearance. Okay, so we are having, you can see from this example, you can see from the nano car to you are having the most luxurious Chevrolet cars. Okay, so that it shows you the aesthetic. Okay, aesthetic or style appearance, that is basically it is aesthetics. Now coming to the next question, that is biomimicry. Okay, what do you mean by a biomimicry? Okay, so this might be a whole new topic for you, biomimicry. So biomimicry, it borrows a nature's blueprints, receives and process an ecosystem strategies, and then comes with a principle to solve your own problems. Okay, so so I'm pretty sure you didn't understand anything. So biomimicry എന്ന് പറഞ്ഞാൽ that is a very recent innovation. Okay, actually it is a very interesting innovation. So biomimicry എന്ന് പറഞ്ഞാൽ here we are actually making true models inspired by the nature. Okay, so from the nature you will be inspiring certain models, and that models will be recreated. Okay, it will be recreated and it will be very efficiently used in our day-to-day life. Okay, okay, for this I will show you one example. Okay, how to from this picture you can see. Okay, so the top of this picture, one second. Okay, so this top of this picture you can see a bird, so mostly this is a woodpecker. Okay, so this bird, okay, the shape of, you can see the shape of this bird. Okay, okay, so this is a bird, so this can fly very fast. Like, this can be flying very fast. Okay, but a bird in the shape, can you see this shape of this bird? Okay, but similar shape inspired in Korea, they have made a model like this. You can, they have made a van like this. So this is basically a train. Okay, a train in the front portion. Okay, so this is basically a train in the front portion. Okay, so basically inspired by the shape of this bird, they have made the front portion of this train into like this. See, no, they have the big beak, or the beak. See the beak of this bird. So similar to that beak of the bird, they have made into this shape. Okay, the front portion of this vehicle has been made into this shape. So this has been done in Korea. So advantage is that it can move faster. Advantage is that it can move faster. Okay, ആ ഒരു ഷേപ്പ് ആയിട്ടാണ് കുറച്ചും കൂടെ എയറിലെ കുറച്ച് പ്രഷർ കുറവായിരിക്കും. Okay, so the vehicle can move faster. Okay, so that's one example. Okay, the second example, you might have seen the syringe. Okay, the syringe, you might are getting injection. Okay, so basically injection nulla ഒരു basic idea from where we have got from the nature. So your mosquito will be biting. Have you seen the mosquito is biting and it is actually taking the blood? You're sucking, the mosquito is sucking blood out of it, blood out of your skin. And the body, the mosquito is taking blood. Okay, but you're not getting wound also. You're not getting wound. Okay, so from that concept, syringes has been developed. Okay, syringes, you can see syringes injection has been developed from that concept. That is, we have inspired from the nature. From the nature, in other, a mosquito is biting you, or any this termite, not termites, any such insect is biting you. it is sucking blood out of it, but you are not actually getting wound. Okay, mosquito biting the സമയത്ത് there is, you cannot even see a minute minute mark also won't be there. Okay, so that our portion, how the mosquito is doing it. Okay, so that has been mimicked in our day-to-day life, and injection or the syringes has been developed. Okay, vaccines also you can see. Okay, so that is actually called as biomimicry. So biomimicry means borrows nature's blueprints. Okay, that is, it borrows nature's blueprint. That is, from the nature you will be borrowing some of its blueprints. Okay, and then you will take it out, you will make your own strategies for this, and you will design principles for this, and you will be applying to your day-to-day life. It will be helping you to solve your problems. Okay, so to understand biomimicry, I will show you some of the importance, some important examples. Okay, so you can accept a design problem from biomimicry. This is a very important. Okay, so see this picture. Okay, so one of the most important example of biomimicry is this shark skin swimsuit. Okay, shark skin swimsuit. Okay, so this now that it has been banned in the Olympics, this swimsuit. Okay, so we'll see what is this shark skin swimsuit. So the shark skin, it is basically okay. So the shark fin, it is made up of a countless number of overlapping scales, which is called as a dermatal denticles. Okay, the shark skin, it is basically, if you see, you cannot see with your naked eye, but if you see under a microscope, normally under an electron microscope, you can see that the shark skin, it is made up of a lot of overlapping scales, which is called as the dermatal denticles. Okay, it is called as the dermatal denticles, or it is also called as a little skin teeth. Okay, now this denticles is actually helping the shark to run to a long distance with the water flow. Okay, so these tentacles is actually that is helping the shark to run through a long distance with the water flow. Okay, so this will actually help to increase the speed of the shark also. That you can, a shark, it is be moving very fast, so that how is that the water, it is having a grooving capacity. This scales, it is having a grooving capacity. അതിങ്ങനെ ഹോൾഡ് ചെയ്യാനുള്ള വാട്ടർ കറൻസിനെ നല്ല രീതിയിൽ ഡിസ്റ്റർബ് ചെയ്യാനുള്ള ഒരു കപ്പാസിറ്റി ഈ ഡെന്റിക്കിൾസ് ഉണ്ട്. ഓക്കെ, ദ ഡെന്റിക്കിൾസ് ദാറ്റ് ഇസ് പ്രസന്റ് ഓൺ ദ സ്കിൻ ഇസ് ഹാവിംഗ് a capacity to break the water currents. So that is called as basically eddies. Eddies are water currents. Okay, so it will disrupt the water currents and it can move faster. So using this denticles, the shark is able to move faster. Okay, so that's one discovery that has been made by the scientist. Okay, so they thought that why can't we do this in our real life. Okay, so similarly, admired by these denticles, they have made a swimsuit. Okay, they have made a swimsuit. Scientists have replicated this dermal tentacles in the swimsuit. The swimsuit, that swimsuit that you are seeing right now, see this swimsuit that you are having, it is having the denticles. It is having the denticles. Okay, they have replicated that tentacles in the swimsuit. Okay, so if you apply this similar denticles below the bottom of the boats also, the boat will be able to move faster. The boat will be able to break the water currents and it can move faster and can go a long distance. And if you replicate this denticles in your swimsuit, you can swim fast. Okay, you can swim very fast. Okay, so this has been used in the 2008 Summer Olympics, but later, now that this swimsuit is banned, all the competitions or the swimsuit or the uh, Olympics, like all the games, they have banned all these models. Okay, so that is one importance of biomimicry. That is, from the nature you are inspiring certain models, and that models will be properly applied to your day-to-day life, and it will lead to the development of the mankind. Okay, so here the scientists have replicated the tentacles in the swimsuit, so the person is able to move very fast, and this is very this is also applied below the bottom of the boat, and the boat is also able to move very fast. But this is banned for all the competition. So that is one example of biomimicry. So another example of biomimicry, I will show you this. This is one of the famous example of biomimicry. That is the termite den. Okay, this is done in Zimbabwe. Okay, this is done in Zimbabwe. So you can see this building. Okay, see this building. So this is a termite den. This is a termite den. Okay, so inspired by the termite den, they have made a building which is called as termite den. Okay, which has attracted the attention of the whole world. Okay, so this was been done in Zimbabwe. So we'll see what it is. So this termite looks okay, the termite dens looks otherworldly, but they are surprisingly comfortable places to live in. Okay, while the temperature outside the swings widely throughout the day, from lows in the 30s to high over 100 degrees, the inside the termite den it holds a steady at a comfortable temperature. Okay, so usually what is happening is that so this one, the peculiarity of this termite den is that so the outside temperature is very varying. We are having from 30 degree to it might goes to some 50 degrees, 60 degrees. If you go to the Gulf countries, 50 degrees. Okay, if you go to African countries, the temperature is even more. Africa, we are having a high temperature. Okay, so that there people are having a high. There people are actually they are the survival to this heat is a very big problem for them. Okay, but if you see a termite den, the inside temperature will be very cool. That is, inside temperature will be very comfortable for this termite den. So scientists have started researching on this termite, how this is being done, how has it been done. Okay, so based on the termite den, they have made a model that is called as a termite den. That is, the peculiarity of this termite den is that whatever may be the outside temperature, the inside temperature will be very comfortable for a human life. Okay, because of the extreme heat you will not be able to work properly. You can see you always need an air conditioning. Okay, so air conditioning is a very costly thing compared to if you go for a high rise building, you need a centralized air conditioning. Okay, so centralized air conditions it will be costing some like lakhs and lakhs and lakhs. Okay, so if you are using such natural techniques, okay, if you are using such natural techniques without the air conditioning, the inside temperature will be very cool and it will be very comfortable for the human life. Okay, so that's a one of the best, you can say, biomimicry that has been done. Okay, this is done in the Zimbabwe. Okay, this is done by an architect that is called as McPherson. He got a lot of awards for this building. That is from the termite den. A similar way, he has made a building, and this building is able to maintain a cool temperature inside. That is, he has actually insulated the building. That is, അതായത് outside നല്ല ടെമ്പറേച്ചർ അകത്തേക്ക് വരാതെ ഇൻസൈഡ് ഉള്ള ടെമ്പറേച്ചറിനെ അവർ മെയിൻറ്റെയിൻ ചെയ്യാണ് ചെയ്തത്. Okay, the outside temperature may be 50 or 60 degrees, that is not able to come inside. ഇൻസൈഡിലെ ടെമ്പറേച്ചറിനെ അവരത് മെയിൻറ്റെയിൻ ചെയ്ത് ഒരു നല്ല വർക്കിംഗ് കണ്ടീഷനാക്കി കൊണ്ടുവന്നു. ഓക്കെ, സോ ദാറ്റ് ഇസ് ബേസിക്കലി എ ടെർമൈറ്റ് den is doing. Okay. Another peculiarity of this termite den is that this building is actually having a large chimneys that will naturally draw a cool air at the night to lower the temperature of the floor slab like a termite den. So, and during the daytime, these slabs retain coolness and reducing the needs of the supplemental air conditioning. Okay, so that's one of the basic of this termite den. അതായത് during the night time it will draw the cool air from the atmosphere. Okay, this termite den it is having large chimneys, and this large chimney will take cool air during the night time. Okay, and this air will be used to cool the floor slabs. this air will be used to cool the floor slabs, and throughout the day a coolness will be acquired in the building. Okay, throughout a coolness will be acquired throughout the building. Okay, the termite also is doing the same. In the termite dens also, they are also using the same technique. That is, they will be having small holes, and through that holes cool atmosphere, or you can say the cool air, will be drawn from the atmosphere during the night time, and it will be stored, and during the daytime it will be used to cool the inside temperature. അതായത് രാത്രികാലങ്ങളിലുള്ള ആ ഒരു തണുത്ത കാറ്റ് അവർ ചെമ്മിണി വഴി പിടിച്ചെടുത്തിട്ട് അത് സ്റ്റോർ ചെയ്യും. എന്നിട്ട് ഈ തണുത്ത കാറ്റിനെ വെച്ചിട്ട് അവരവരുടെ റൂമിനെ കൂൾ ചെയ്യിക്കും ഡ്യൂറിങ് ദ ഡേ ടൈം. ഓക്കെ, സോ ദാറ്റ്സ് എ ബേസിക്, ഇറ്റ്സ് വെരി ഫ്രീ ഓഫ് കോസ്റ്റ് അല്ലെ, നമുക്ക് അറ്റ്മോസ്ഫിയറിൽ നിന്ന് കിട്ടുന്നതാണ്. ഓക്കെ, അപ്പൊ ഈ കൂൾ എയർ സ്റ്റോർ ചെയ്തിട്ട് ഈ കൂൾ എയർ വെച്ചിട്ടാണ് ഡേ ടൈമിലെ എയറിനെ അവർ കണ്ടീഷൻ ചെയ്യുന്നത്. Okay, so similar to that termite den. So this idea they got it from the termite den. Okay, അപ്പോൾ അതുകൊണ്ടാണ് ആ ഒരു pyramid piers that similarly he has made an building that is called as termite den. Okay, so that is one of the most famous biomimicry that has been done. Okay, I'll show you another biomimicry. See, velcros. നമുക്ക് എല്ലാവർക്കും അറിയാം velcro. Okay, so you might be using this, is might be using in your bags. Okay, see this sticking thing അല്ല, നമ്മളിങ്ങനെ ഒട്ടിച്ചു വെക്കുന്ന ഒരു സാധനമാണത് velcro. Okay, this is used as a straps in your shoes, not shoes, in your sandals. Okay, sandals straps that you use, sometimes this is also used in the bags. Okay, velcro from where they have got this idea, that is from the nature. See, from the nature learn they have got this idea of velcro. See, okay, so velcro is one of the well-known biomimicry. Okay, so you might have worn shoes with velcro straps as an youngster. Now also you will be wearing. Okay, so this has been invented by a Swiss engineer, George D. Meister. Okay, so this is the engineer who has done it. George D. Meister. So you don't need to study the name of this engineer and all. This is just for the information. You just need to understand what is biomimicry and how it is working. Okay. So how it is that the small hook that is found at the end of the burr needles inspired by him to create a now ubiquitous velcro. Okay, without its material the world doesn't know the velcro jumping, a sport in which people dressed in the full suits of velcro attempt to throw the bodies as high as wall as possible. Okay, അതായത് see, ഇതുപോലെ ഒരു നേച്ചറിൽ നിന്ന് അയാൾക്ക് ഇൻസ്പയർഡ് ആയിട്ട് കിട്ടിയ ഒരു സംഭവമാണ് ഈ വെൽക്രോ എന്ന് പറയുന്നത്. Okay, the person, the engineer, after seeing this biomaterial, okay, ഇത് നമ്മുടെ നേച്ചറിൽ കാണുന്ന ഒരു മുള്ളുള്ള ഒരു പൂവാണിത്. Okay, ഒരു മുള്ളുള്ള സംഭവമാണ്. So from this he thought that why can't we recreate the similar thing in our day-to-day life. ഇത് വെച്ചിട്ട് ഇൻസ്പയർഡ് ആയിട്ടാണ് he has made this velcro. So now that velcro, it is used in all of the shoes, bags, sandals, everywhere it is there. Okay, so it's one of the well known biomimicry. So what do you mean by biomimicry? Biomimicry എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ നേച്ചറിലുള്ള ബേസിക് ആയിട്ടുള്ള നാച്ചുറൽ footprints you are recreating in your day-to-day life. Okay, another example you can see. Okay, our aeroplanes. Okay, aeroplanes. So the shape of this aeroplane is similar to that how bird is flying. Hello. Okay, why means through this shape, the shape of the bird you might have seen. Okay, so by the shape of the aerofoil shape, sorry. So by this, the drift and drag of the air can be properly handled and you can move in air faster. Similar to ആ ബേർഡിന്റെ ആ ഒരു സ്ട്രക്ചറിൽ നിന്നാണ് എയറോപ്ലെയിന്റെ സ്ട്രക്ചറിലേക്ക് നമ്മൾ ഡെവലപ്പ് ചെയ്ത് വന്നത്. Okay, so that's another biomimicry. So that is basically called as biomimicry. And biomimicry, please try to understand, this is very, very important. Okay, you can definitely accept And question from this biomimicry. So see termite dens. Okay, one of the most important. So in the termite dens in the inside temperature will be always cool. That means a termite is able to survive in that. Okay, so that's how termites is surviving even the extreme temperatures. Our concept at the time they have constructed the termite den. Okay, so Zimbabwe, you know, this is basically an African country, and there the temperature is very high. Okay, so people cannot go outside or people cannot work in such high temperatures. Our temperatures our extreme temperatures survive വേണ്ടിയാണ് they have made a termite den. Okay, the same technique that is used in this termite den is used in this building also. That is, they are drawing air from the atmosphere during the night time. They will store it and they will use it for the daytime. Another example, shark in the swimsuit, shark swimsuit. Okay, it is called as a shark swimsuit. Now it is banned for the competition. Okay, that is the tentacles that is present in the shark skin is actually helping the shark to move it faster. Okay, so same the tentacles has been recreated by the scientist in a swimsuit, and also it has been applied in the bottom of a boat also, so that the boat can move faster. The person who is wearing this swimsuit, he can also swim faster. Okay, so that is another biomimicry. So this is very important question. So biomimicry. Now once again I will go to the definitions of the biomimicry. So biomimicry the concept and then once like remaining you will be having a design question. Okay. So biomimicry then basically it will be borrowing nature's blueprints, receives, process and ecosystem strategies and then come up with a design principle to solve your own problems. അതായത് നേച്ചറിൽ നിന്നുള്ള ബേസിക് ആയിട്ടുള്ള ഫുഡ് പ്രിന്റ്സ് യു വിൽ ബി അഡോപ്റ്റിംഗ് ഇറ്റ് ആൻഡ് യു വിൽ ബി പ്രോസസ്സിംഗ് ഇറ്റ് into your own design principles, and finally you can solve the day-to-day problems of your life. Biomimicry, that is biomimicry. Okay, next we'll go back to the third module. Okay, we'll go back to the third module and we will see how to solve some of the problems. Okay, we will see how to solve some of the problems, design problems. So this is one of the previous year questions. So question is that graphically communicate the design of dash, the draw a 2D details of the same with the design detailing, material selection, scale drawing, dimensions, tolerance, etc. Use the hand sketches only. So I have used the same question for the university also, but the material is different. Okay, so today we will discuss about the design of a sofa here. Okay, here now we'll design a sofa. Okay, the first question is graphically communicate the design of a sofa. That is a previous year question. Okay, number sofa design you are doing here. Okay, so you have to prepare a 2D drawings, a design detail, material selection, scale drawings, dimensions, tolerance, etc. So how will you do it? Not sofa. You will be designing a microwave oven. Sorry, not sofa. That is, you will be designing a oven here. Okay. Okay, just please take just 1 minute to think about this question. Okay, so design means basically this is your ideas. So the question is graphically communicate the design of an oven. Okay, you have to develop a design of an oven with a proper design detailing, material selection, scale drawing, dimensions and tolerance. So this is basically from the third module. So third module you have you have studied about the material selection, scale drawing, different types of sketches, different type of drawing, so many things you have studied. Okay, all these things you have to apply here. So how to do that? And one thing they have told you to use hand sketches. Okay, so you have to draw anyhow. So just take 1 minute to think about this question. how to design an oven. Okay. Okay, now I'll start with this. Oven means basically they are used to bake cakes. Now there are some advanced oven is that in that you can actually fry chickens, you can fry fishes, etc. Also. Okay, that depends upon the size. Okay, and oven it comes from the different size. From a small oven, that is from a 1 liter oven, to now that it is available to 5 liter, 6 liter, 7 liter oven. Capacity of oven is also different. Okay, so oven is basically it ranges from a small size to big size. Okay, so why it is used? Basically it is used to bake a cake, or you can use to fry some materials, or you can cupcakes, or you can say your puffs, everything that is baked inside a oven. So see this, this is a oven, this is a 2D. So here they have asked to draw the 2D drawings. Okay, two dimensionally how you are seeing an oven. So this is a picture of a different types of oven that is found in the market. Okay, so similarly this type of idea should be there in your mind. Okay, but different types of oven that is found in the market. Okay, okay. So some oven is having a single rack. There are oven which is having two racks also. See this. Okay, these are single rack ovens. So the below you can see the oven which is having two racks. Two racks will be there. Okay, then there will be separate box, sorry, separate switch to control the temperature. Okay, and to for the cooling purpose, everything. So the two rack oven also you can see that some first model, the top oven is big and bottom oven is small. Okay, coming to the second one, you can see both the racks, both the oven, both the compartments are having equal shape. Okay, now coming to the third one, even in pretty much advanced, you can control the temperature for both the racks. Okay, similarly ഓരോരോ properties അങ്ങനെ vary ചെയ്തുകൊണ്ടിരിക്കും. So all these things depends upon your design thinking. Okay, so this is basically a 2D drawing, or a 2D drawing manner. This is how to draw it. Now they have asked you to detail. See, they have asked to make a detail about the details, material selection, scale drawings, dimensions and tolerance. അപ്പോൾ ഇത്രയും കാര്യങ്ങൾ നിങ്ങൾ ഡ്രോയിങ്സിൽ ഇൻക്ലൂഡ് ചെയ്യണം. Okay, all these things has to be included in your drawings. So see this drawing. So this is a drawing which actually include all the details about the microwave oven. Okay, so type of design is your option, which whether it is a single rack or whether it is a double rack, whether it is a big oven, that depends upon it. They have not mentioned anything about that. They have just asked to design an oven. Okay, ഒരു ഇന്നോവേറ്റീവ് ആയിട്ടുള്ള ഒരു ഓവൻ. അപ്പൊ ആ ഒരു ഓവനിൽ you can see the dimensions. See, so when you're designing an oven, you should have a proper idea about the dimension. That is, it should fit a kitchen. Okay, so some kitchen will be small, some kitchen will be big, so that varies. Okay, so the oven has to be comfortably fit in every sizes of the kitchen, and it has to be user friendly. The person should be able to use it. Okay, so for that you have to give a proper dimension for this oven. See this, they have mentioned all the dimensions in this picture. They have mentioned all the dimensions. Okay, the door dimension they have mentioned, the top dimension they have mentioned, the total overall dimension they have mentioned. So you can see the trace in the dimension they have mentioned. See, they have shown the rack outside. Okay, they have took the rack outside, and the rack in the outer dimension they have shown you. Okay, so each and every dimension they have shown here. Plus, they have also mentioned the materials that they are using. So we are having different types of material, thermostatic materials. Okay? That is, the material should be able to withstand the high temperatures. Okay, for thermo-resistant materials that has been used here is also mentioned in the picture. Okay, so you have to mention about the materials. So what kind of materials you are using, why you are using it, all these things you have to mention. Okay, this is a detailed drawing. This is how you have to recreate your drawing. Okay, so here also you can see similarly microwave oven each and in the second picture, see the second picture. Okay, second picture they have, see, this is an oven with the two racks, and two racks in the inside dimension, rack dimension, outside dimension, overall dimensions, everything they have mentioned here. Okay, so that is a detailed drawing has been mentioned. Okay, so similarly, when a question is given to you, you have to create a model like this. You have to create a model like this. First you have to make a plan like this. Okay, just first you have to make a front view like this. After that, create the detailed drawing. You have to create a detailed drawing. What will be the inside portions, all these things you have to create. Okay, so basically this problem doesn't the person who is examined doesn't see the beauty of the drawing. He will be only seeing what idea you are incorporating in this question. Okay, what are the ideas that you are having and what is the design thinking that you are using in this question? That will be the basic valuation point for this type of design questions. Okay, so you have to keep that in mind. See another picture. Okay, the cases, how they are using cases, door front, all these things they have mentioned, the pans and the dimensions and gyro, they have mentioned it. Okay, so this is how you have to deal with a question like this. Okay, so here you have to mention about the, you have to specify the dimension, the scale which is you are drawing. Okay, what scale you are using. Now the measurements of different racks, cabins measurements you have to mention, and you can create a table also. Okay, you can create a table mentioning the bottom portion, the rack portion, the front portion, or the door, all these things you can mention, and you can mention the specific dimension. Then label each and every part. Label each and every part. Then you can add a note like you are suggesting a material like this so that it will be more thermostatic, and a correct suggestions also you can make. Okay, next one is scale. Next one is tolerance. Okay, so tolerance basically means either see this picture. So here in this picture, see this, the door front they have made so as a designer, door front you have made into 595 centimeters. Okay, your plan is to make into 595 and 454 centimeter. But നമ്മളത് ചെയ്തു വരുന്ന സമയത്ത് during the practical, okay, we will not be able to correctly make a 595 or 454 centimeters. So you can allow us some tolerance, like 595 may become a 590 or 596 or 597, or sometimes it will become 590 also. A 5 mm plus or minus may occur. That may also occur in the similar case of 454 also. You will not be able to depict the 454. Sometimes 450, sometimes it will be 452, 453, or sometimes it will be 457. Okay, or a plus or minus 4 mm can occur there. So that is called as tolerances. That is, some variations in the measurements will occur. Okay, so you can allow some variations. ഒരു 5 ഒരു 5 mm കൂടിയാലോ കുറഞ്ഞാലോ വലിയ പ്രശ്നമൊന്നുമില്ല. That is called as tolerances. Okay, so that also you have to mention. Now coming to the second question, this is another university question. You have to design a role of a mathematical modeling in designing engineer. Okay, design the role of mathematical model in design engineering and show how the mathematics and physics can play a role in designing a lifting mechanism to raise 100 kg of weight to a floor of a height of 10 meters to a construction site. Okay, so this is a university question. First portion you can answer. Describe the role of mathematical model that you know. Okay, that is a theory question. Basically, I have given the PPT. That's it. Now, second question is that you have to apply the mathematical model into a practical area. That is, you have to design a lifting mechanism. You have to develop a lifting mechanism which will lift a 100 kg weight to a height of 10 meters. So, using some maths and physics. So, how to do this? Okay, so this is a university question. I'll tell you how to solve this. So lifting mechanism basically what is something that is used to lift the height. Maybe it's a person, maybe it's a cargo, whatever it is. In the building learning, we are also having lifting mechanism. Sometimes it will be like this. Okay, that depends upon your idea. Okay, sometimes it will be like this, sometimes it will be like this, or sometimes it will be like this. You can also use cranes also. Okay, in the construction sites, people are also using cranes also. They have just mentioned a lifting mechanism. Okay, so how to use a max model in it, how to use a physics in it. Okay, so lifting basically means what is actually happening here. So in this all these three models, you might have observed that the basic thing that is functioning is the force. That is, you have to lift a load. You have to lift a load to a height. ഒരു ലോഡിനെ ഒരു ഹൈറ്റിലേക്കാണ് ലിഫ്റ്റ് ചെയ്യുന്നത്. Okay, that is a load. Load means what? A force ആണ്. Okay, a force has been lifted to a distance. Okay, so that means what is work is happening there. Okay, so work എന്ന് പറഞ്ഞാൽ എന്താ? Force into distance. Work is force into distance. Okay, so ഈ work ചെയ്യാൻ വേണ്ടിയിട്ട് what you need? You need power. You need power to do the work. So basically in all these three models, you need to calculate the power. അതായത് എത്രത്തോളം പവർ ഇവിടെ വേണം ലിഫ്റ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട്. That's the first thing you have to calculate, and that's the physics portion here we are using. Okay, so power means work divided by 10, the work that is done in a specific time. Okay, so work means what? Force into displacement. Okay, that is the force which has been displaced, that is called as work. What do you mean by force? Force is mass into acceleration. Okay, so here let's calculate it. Okay, so here force is mass into acceleration. Mass they have given, right? 100 kg. The question they have given, the mass is 100 kg. 100 kg nalla mass and you have to lift to a height of 10 meters. Okay, so mass is 100 kg. Acceleration, you can take it as acceleration due to gravity, that is 9.81. Okay, so you will get the force. If you get the force, you can calculate the work. Okay, so force നമുക്ക് കിട്ടിക്കഴിഞ്ഞു. Now next is you can calculate the work. So work means force. So this is force, mass into acceleration. This much is force. Okay, mass into acceleration, m into a into 10 displacement. Okay, you have to lift the 10 kg to a height of 10 meters. 10 meter ആണ് പൊക്കി കൊടുക്കേണ്ടത്, but 10. So you got it as 9810 joules. Okay, next is you can calculate power. Power means work by time. Time they have not given. Okay, you can assume it. You can take it as 1 minute, you can take it as 1 hour, or you can take it into seconds also. So here I have taken in seconds. So 9810 divided by 60 seconds, that is 163.3 watts is required. Okay, so basically for this lifting mechanism, to lift 100 kg you require 163.3 watts. So that is the need of a physics and max here. So this is the physics and max model that has been used here. Now we'll see how to solve this problem. Okay, so prior to solving, first you have to see why you are using this model. Now that you have developed a lifting mechanism. Okay, why you have developed this lifting mechanism, what is the use of it? Okay, next is you have to define the importance of this physics and max in this lifting mechanism. Next is the available data, whatever the data they have given. Okay, next is assumptions, you have assumed the time. Okay, പിന്നെ നെക്സ്റ്റ് വരുന്നത് ഏറ്റവും ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള കാര്യമാണ് ഡയമെൻഷൻസ്, യൂണിറ്റ്സ് ആൻഡ് ഹൗ ക്യാൻ ബി ഡെവലപ്ഡ്. ഒരു ലിഫ്റ്റിംഗ് മെക്കാനിസത്തിനെ how can you make into a proper lifting mechanism? Okay, so you have to mention the dimension, you have to mention the units, and you have to put your creative idea how can you develop into a best lifting mechanisms. Okay, and അതിൻ്റെ ഒരു add on points എന്ന പോലെ you can give some of the tips to improve the design. That is, you can use different system, hydraulic system you can use. Okay, or also you can use some electric systems. Okay, so that you can use, so that it will be lifting more than 100 kgs. That is, if you are using hydraulic or if you are using electric system, it will be able to lift from 200 kgs to more heights. That is, now that you have also 100 10 meters, it will be used for lifting some 20 or 25 meters. Okay, അതൊരു ആഡ് ഓൺ പോയിന്റ്സ് ആണ് നമ്മൾ ഡെവലപ്പ് ചെയ്തതിന്റെ ഒരു ജസ്റ്റ് ഒരു ആഡ് ഓൺ പോയിന്റ്സ് പോലെ you can add, if you use this system, it will be able to develop more efficiency. The efficiency will be developed. Okay, so this is how you have to answer this type of questions. Okay, now that you can post your name to mark the attendance. So tomorrow, one more hour is there. So are you clear? Just tell me, are you clear about this design problems, how to solve this design problems? So basically, this is your ideas. അതായത് നിങ്ങൾക്ക് നിങ്ങളുടെ ഇഷ്ടമുള്ള രീതിയിൽ ഐഡിയാസ് ഇവിടെ കൊണ്ടുവരാം. ഒരു മാൻഡേറ്ററി ആയിട്ടുള്ള റൂൾസ് ഒന്നും ഇല്ല ഇവിടെ. ഓക്കെ, ഒരു ഇന്നോവേഷൻസ് ആണ്. ഡിസൈൻ മോഡൽസ് പറഞ്ഞാൽ ജസ്റ്റ് ഒരു ഇന്നോവേഷൻസ് ആണ്. ഓക്കെ, അപ്പൊ അവിടെ നിങ്ങൾ ചെയ്യേണ്ട ബേസിക് ആയിട്ടുള്ള കാര്യങ്ങളാണ് ഇത് മാത്രം. ഓക്കെ, if you're taking lifting mechanism, the basic thing, okay, why you are using this model, you have design നിങ്ങളുടെ മനസ്സിൽ ഒരു മോഡൽ ഉണ്ട്. So this is a commonly used model. ഇതുപോലത്തെ മോഡൽസ് യൂസ് ചെയ്യാം, ഇതുപോലെ മോഡൽ യൂസ് ചെയ്യാം, depends on it. Okay, so whatever the model you are using, why are you using that model, that's the first point you have to mention. And what is the use of that model? ആ മോഡലില് നിങ്ങൾ ഉപയോഗിച്ചിരിക്കുന്ന ഫിക്സിക്സ് മാക്സിനെ പറ്റി പറയാം. പിന്നെ തന്നിരിക്കുന്ന ഡാറ്റാസ് എന്തൊക്കെ നിങ്ങൾ അസ്യൂം ചെയ്തു, പിന്നെ ഡയമെൻഷൻസ്, ഓക്കെ, നിങ്ങളുടെ ഡിസൈൻ മോഡലിന്റെ പ്രോപ്പർ ആയിട്ടുള്ള ഡയമെൻഷൻസ്, ആൻഡ് ഹൗ ടു ഇംപ്രൂവ് ദാറ്റ് സിസ്റ്റം ഇൻ ഫ്യൂച്ചർ. Okay, if you use hydraulic system, if it's electric system, you can make more developments in this lifting mechanism. That also you have to include as an add-on points. Okay, so that is basically mathematical modeling. അതിനാണ് mathematical modeling എന്ന് പറയുന്നത്. I think it's time now. Hope you are. So if you're having any doubts, just contact me. Okay, I think it's okay. Thank you.